All right, guys, let us quickly touch this topic, vibrating string. Okay, so first of all, you know what a string is. Like, it can be any flexible object that can transmit waves when stretched or disturbed. That is a string. So now let us consider this scenario where you are holding a rope, a string. Okay, you fix one end of the string and you are holding the other end of the string. You are holding the other end. Now, you are now vibrating the other end. That is the one you are holding up and down. You are vibrating it like this. As you are doing this thing, progressive waves will be forming on the string. You know, a string, like I defined, it transports what waves. Is a flexible object that can transport waves. Now, as these waves are forming, remember you fix the string at the other end. Now, when the waves goes to the other end, they will be reflected. There will be a reflection. So, but you will not notice the reflection until you are vibrating at the right frequency. That is when you are vibrating the string at the right frequency. At that frequency, which we call the natural frequency of the string. The reflected wave and the wave, that is the progressive wave. The reflected wave is also progressive. Do you understand? Both the one that you caused and the reflected wave, they are both progressive waves. Now, if you vibrate it at the right frequency, a pattern, a form will exist, okay, such that there will be maximum displacement. There will be part of maximum displacement and part of zero displacement, which we call antinode and node, when you are vibrating the string at the right frequency. Now, see the form here. You have a waveform like this. To look like this. Remember, this is the one. This is where you are holding. You are holding the string here. This is the wave that is traveling from you to the other end. Now, this is the reflected wave. So this thing happens when you are vibrating this string at the right frequency. We call this frequency the natural frequency, okay, of the wave, the natural frequency or the fundamental frequency. Okay. Now, let's fundamental frequency. We call it F0, fundamental frequency. Now, you are still holding the rope. As you continue to increase the frequency, a point will come when the frequency that you increase to, if it is 2 times this fundamental frequency, see what you will see. You will see a waveform like this. You will see a waveform like this. It will appear like this. Okay? Do you know why? Because a resonance has occurred. All those why it is vibrating like this. You are increasing the vibration, but you will not see this thing. But once the frequency that you are using to vibrate that it is vibrating with, once the frequency is 2 times this one, it will appear like this. You will see this form like this. So this one is we call it second harmonic. This one can be called first harmonic. First harmonic. This one is what? Second harmonic. Second harmonic. Or we can call it also or first overtone. First overtone. Yes. We can have infinite numbers of harmonics. As far as you are increasing the vibration, if it is 3 times the fundamental frequency, this thing will appear 3. Yes, you will see it will just appear 3 times. It can have so many frequencies, so many. This thing can be, it can be infinite. Do you understand? So next class, I will now show you like a general formula, okay, that relates all these things. That is all the frequencies to the length of the string. You know, this string has a length L, okay? That will be for the next class. I will now show you the formula that relates all these things, okay? See you guys in my next class.